Hi, I'm Julian Marfori and I'm the team leader of Team 3.
Hi, my name is Andrea Luis Custodio and I'm one of the members of Team 3.
I'm Piora Francine De La Torre and I am a member of Team 3.
Hi, I am Pamela Orega-Disan, a member of Team 3.
Hello everyone, I am Liza G. Franca.
I'm Mariana Micaela J. Uy, a member of Team 3.
I am Hezekiah Uy, a member of Team 3.
So what is integration? Integration computes the antiderivative of a function using substitution rule and tables of integral, including those antiderivative involve logarithmic and inverse trigonometric functions. It also computes the general antiderivative of polynomial, radicals, exponential, and trigonometric functions. To understand more about the topic, here is my friend Piora to give an example and explain.
Before I'll give the example, I would like to thank Pamela. And now, going back, here is a sample equation for the integration. The given example is the integral of sine x over cosine squared x plus x and dx. First, we're going to solve the part excluding the x, which is the integral sine x over cosine squared x and dx. First, we're going to apply the u substitution where we let u be equivalent to the cosine x. Then, we find its derivative, or du, which is negative sine x. Lastly, the negative du. The latter is achieved by multiplying both sides of du by negative 1, which answers to sine x. After we are done with the u substitution, we can now substitute the cosine squared x to 1 over u squared, then sine x and dx to negative du. We bring out the negative sign from the integral, which will now become 1 over u squared du. We will change the fraction into indices form, which will now become negative integral u and negative squared du. The next thing to do is to apply the power rule, which will now become negative u negative squared plus 1 over negative 2 plus 1 plus c. We will transform it and we will now have negative u negative 1 over negative 1 plus c, or in simpler form, u negative 1 plus c. This is the same to 1 over u plus c, where we substitute u to cosine x, and now we have 1 over cosine x plus c, which is the same as secant x plus c. We are done from the first part, and now we are going to solve for the last part, which is x. We are going to apply the power rule, x n plus 1 over n plus 1, which will now become x 1 plus 1 over 1 plus 1. And the answer is x squared over 2 plus c. After solving for x, we go back to the equation, which is sine x over cosine squared x plus x and dx. Since we already found the answer for the first part and the last part, we will now substitute them into the equation. We're going to put the answer in the last part, which is x squared over 2, plus the answer from the first part, which is x plus c. Now, that is the end for this example. Once again, I'm Tiara Francine de la Torre, and I hope you have learned something from today's integration example. Thank you.
This concludes the lesson. Hopefully, you have now a clear understanding of how to solve the integration. But remember, you'll need to work to master it. Thanks for watching our tutorial, and I'll see you next time. Bye!